and put that value here in the last equation. A plus b is equal to 2, where b is equal to 2, so a is 0. So here is our coordinate vector relative to the basis S. What is ABC? A is 0, B is 2, C is minus 1, so 0, 2, minus 1. So this is a required solution of this question. We already proved that the set S is a basis for the vector space V, vector space P2, and here there is a coordinate vector of P relative to the basis S, that is 0, 0, 2, minus 1. Okay, so next question, question 4a, second part. Use appropriate identities were required to determine which of the following sets of vectors in F minus infinite to infinite are linearly independent. This question was asked in 2 marks in this question paper, and here we have to solve these 2 examples. The first one is x into cos x, and the second one is cos 2x, 3 functions cos 2x, sin square x, and cos square x. To prove these 2 are linearly independent and linearly dependent, we have to use Wronskian determinant, right, to check. So the Wronskian for the function f of x is equal to x and g of x is equal to cos x is given by w of x is equal to fx gx f dash x g dash x, x cos x fx gx. Instead of fx and gx we have x cos x, and instead of f dash x g dash x we have 1 minus sin x. To solve this determinant, this is minus x sin x minus cos x. So w of x is not equal to 0 for all x in minus infinite to infinite. So f of x and g of x are linearly independent, they are not dependent. Okay. The next is second part. This is cos 2x sin square x cos square x. So to find Wronskian determinant, we need f1 dash x, f2 dash x, f3 dash x, f1 double dash x, f2 double dash x, right, the first and second derivative of all the 3 functions. So let's first of all find the derivative of all the 3 functions f1, f2 and f3, first and second derivative, right. So here is cos 2x. So the derivative of cos 2x, that is sin 2x, and the derivative of 2x is 2. The derivative of cos is minus sin, so minus sin 2x, and the derivative of 2x is 2. So here we have minus 2 sin 2x. The sin square x, that is derivative of sin square x is 2 sin x cos x, and the derivative of f3x, that is equal to minus 2, the derivative of cos square x, that is 2 cos x, and the derivative of cos x is minus sin x, so the minus 2 cos x sin x. Okay. Now we know that 2 sin x cos x, that is sin 2x, so this is actually sin 2x, right. Similarly here 2 sin x cos x, that is 2 sin 2x. Now the derivative of minus 2 sin 2x, that is minus 4 cos 2x, and the derivative of sin 2x, that is 2 cos 2x. Again the derivative of minus 2 sin 2x, that is minus 2 cos 2x. Put all these values in this Wronskian determinant. The formula of the Wronskian determinant, that is the first row is f1, f2, f3, the second row is f1 dash, f2 dash, f3 dash, and the third row is f1 double dash, f2 double dash, f3 double dash. So put all these values in this determinant. Cos 2x sin square x cos square x, minus 2 sin 2x minus sin 2x, minus 4 cos 2x, 2 cos 2x, minus 2 cos 2x, right. Now you can see to solve this determinant, here we are using some properties of the determinant, that is see, sin 2x is common from this second row, right, in all the element in all the place of the second row we have sin 2x, so that's why sin 2x will be common. From the third row you can see 2 cos 2x will be common, 2 cos 2x, 2 cos 2x sin 2x, right. So in determinant cos 2x sin square x cos square x, the second row is minus 2 1 minus 1, and the third row is minus 2, 1, minus 1. Now the second and third row are as it is, so that's why this equal to 0. Okay, the second and third row in the determinant, there is one property for the determinant, that if we find the value of the determinant f, and if any two row are same or any two column are same, then definitely the value of that determinant is equal to 0. So that's why the value of this determinant definitely is equal to 0, and so that's why these are not linearly independent, these are linearly dependent. Okay, these are linearly dependent. So here is a complete the solution. Here we have two examples, and we have to check that that functions are linearly independent or dependent. The first one is linearly independent and the second one is linearly dependent set of functions, right? And this question was asked in 2 marks in this question paper. Next question, question 4b. Find the rank and nullity of the matrix A, where A is equal to 3 cross 4 matrix. The first row is minus 1 4 5 2, the second row is 2 1 3 0, and the third row is minus 1 3 2 2. This question was asked in 4 marks. Here is the solution, like A is equal to 1 4 5 2 2 1 3 0 and minus 1 3 2 2. So first we have to convert this matrix into a row echelon form. As I told you that what is the meaning of row echelon form and how to convert any matrix into a row echelon form, that you should know. So in the first row, this is our leading entry. Below that leading entry I want 0 here, so that's why we multiply first row with minus 2 and add into the second row, and multiply first row with 1 and add into the third row. So the first row is as it is, 1 4 5 minus 2, right? Sorry, this is only just a 2, and the second row become 2 minus 2 0, 1 minus 8 minus 7, 3 minus 10 minus 7, 0 minus 4 minus 4, right? This is 2. Okay, this is a correction, here not minus 2, this is 2 because of first row is as it is here. The third row, the first next we multiply first row with 1 and add into the third row, so that's why minus 1 plus 1 0, 3 plus 4 7, 2 plus 5 7, and then 2 plus 2, that is 4. Okay, so next is in second row, this is our leading entry, correct? We multiply second row with 1 and add into the third row, so the third row becomes 0, because see, in second and third row all the elements are same, just difference is only for the sign, right? So when we multiply second row with 1 and add into the third row becomes 0, correct? So 1 4 5 2, the first row is as it is, the second row becomes 0 7 7 minus 4, and also we multiply second row with minus 1, so this minus sign will be cancelled out. Here 0 7 7 4, and this is 0 0 0 0. Okay, now you can see in this in this matrix we have two non-zero rows, we have two non-zero row. Okay, and we have two non-zero row. So what is the definition of rank in any matrix? If you want to find the rank of that matrix, first of all you have to convert that matrix into a row echelon form or reduced row echelon form, and whatever the non-zero row, whatever the number of non-zero row, that is exactly the rank of the matrix. So here we have two non-zero row, so that's why the rank of the given matrix is 2. And to find nullity, we can use rank nullity theorem. The last matrix is in row echelon form, and rank of A is equal to number of non-zero row, that is equal to 2. Now by rank nullity theorem, rank of A plus nullity of A, that is equal to number of columns of A. Okay, that is equal to number of columns of A. How many number of column in this matrix? 4 number of column, correct? And So 2 plus nullity of A, that is equal to 4. So nullity of A is equal to 4 minus 2, that is equal to 2. So rank of A is 2 and nullity of A, that is also 2. Okay, so here is the complete solution of this question. The next question, question 4c. Using the Cramer's rule to solve the system of equations. Here we have three equations. The first one is x1 minus 3x2 plus x3 is equal to 4. Then 2x1 minus x2 is equal to minus 2. And then 4x1 minus 3x3 is equal to 0. And this question was asked in 3 marks. First of all, we find the determinant, call it capital D, which are the coefficient of the x1, x2, x3 in each of three equations. The first row is coming from the first equations, that is a coefficient of x1, x2, x3 in the first equation, that is 1 minus 3 1, 1 minus 3 1. The coefficient of the second equation, the coefficient of the x1, x2, x3 in the second equation, that is 2 minus 1 0, and the coefficient of the third equation, that is 4 0 minus 3, that is equal to 1 into 3 plus 3 into minus 6 plus 1 into 4, that is equal to 3 minus 18 plus 4, that is equal to 7 minus 18, that is equal to minus 11, not equal to 0. Okay, so this determinant is not equal to 0, so that's why we can solve this system of linear equation using Cramer's rule, and solution is exist. Now find another three determinant, call it d1, d2, d3, where d1 is exactly this determinant, but the first column, remove this first column from D and add this constants 4 minus 2 0, which are the right hand side part of three equations, 4 minus 2 0. Okay, so you can see 1 2 4 are removed here, 1 2 4 which we remove, the first column is removed, and instead of that first column we have to add 4 minus 2 0. All other elements are same, minus 3 1, minus 1 0, 0 minus 3, all other elements are same, correct. Now this is equal to, now solve this determinant, that you should know that how to solve the determinant, that is 4 into minus 1 into minus 3, that is 3, plus 3 into minus 2 into minus 3, that is 6, plus 1 into 0, that is equal to 12 plus 18, that is equal to 30. Okay, 12 plus 18, that is equal to 30. Now d2, similarly we can find d2 also, that is equal to the second column, instead of second column 4 minus 2 0, minus 3 minus 1, remove minus 3 minus 1 0, and from that minus 3 minus 1 0 we have to add 4 minus 2 0. Other first and third column are as it is, you can see 1 2 4 and 1 0 minus 3, 1 2 4 and 1 0 minus 3. Okay, so only the second column is 4 minus 2 0 now, and now also solve it. 1 into 6 minus 4 into 2 into minus 3, that is minus 6, and there is a 0, then plus 1 into, there is a 0, 2 into 0 0, then minus 2 into 4, that is 8. So 6 plus 24 plus 8, that is equal to 38. Similarly you can also find d3, that is equal to 1, the first row is 1 2 4, the first column, first and second column are as it is from this d, 1 2 4 minus 3 minus 1 0. Okay, 1 2 4 minus 3 minus 1 0. The third column is 4 minus 2 0, the third column is 4 minus 2 0, and that is equal to 1 into minus 1 into 0 0, plus 3 into 0 plus 8, so that is 8, plus 4 into 0, 2 into 0 0, minus 4 into minus 1 plus 4, so 4, so 8 into 3, that is 24 plus 16, that is equal to 40. Clear? So we find all this determinant. First of all we find capital D, then D1, D2 and D3, and here is the equations. Here is the formula to find x1, x2, x3. x1 is exactly the capital D1 upon D, which is what is our capital D1? This is 30 and this is minus 11. So 30 upon minus 11. This is x2, D2 upon D, that is 38 upon minus 11, and this is x3, D3 upon D, that is 40 upon minus 11. So the final solution is x1, x2, x3, that is equal to minus 30, 11, minus 38 by 11, and then minus 40 by 11. So here is a complete the solution of up to this question. Thank you.